Now my dear students, we can see the question number 16 in structure of atom. The energy of a second Bohr orbit of the hydrogen atom is minus 328 kilojoule per mole. Hence the energy of fourth Bohr orbit would be, my dear students, first of all you can write formula to get the energy of an electron in different shells. Here Bohr give us energy of electron, and that is En, that equal to, my dear students, En is equal to minus k z upon k is a constant, z upon n ka whole square or z square upon n square. Here we can see here it burns second Bohr orbit of the hydrogen atom. So you can say the minus k into, here z is equal to 1 for hydrogen atom upon n is the second Bohr orbit, means n square means 2 ka square. That's why, my dear friends, you can get this is a 2 ka square. So my dear students, you can get the minus k upon 4, and here energy is given by 328 kilojoule, means minus k upon 4, it is the E2, that equal to E2, because here it's a obtained from the second Bohr orbit. It is obtained from the second Bohr orbit. That's why minus k upon 4, that equal to E2. Here, my dear friends, this E2 is equal to minus 328 kilojoule, which is given in the numerical, okay, and this 328 kilojoule. So my dear students, here minus k or k is equal to, here you can see this 4 is multiplied by this 328. So you can say that minus minus cancel. So you can get the k is equal to 4 into 328 kilojoule. It is the values of k. Now here he asks hence the energy of fourth Bohr orbit. So my dear students, in fourth Bohr orbits, we can see the energy for fourth Bohr orbit, that equal to minus k, that equal to minus k into 1 upon, for fourth, 4 fours are 16 upon 16. This energy you can get. Here you can see that E4 is equal to, that equal to minus, here you can put the values of k. So minus 4 into, this is 4 into 328 into 1 into, this is the z is equal to 1 upon 16. So my dear students, you can get the energy. Question number 16, you can get the energy, that is minus 1, you can get the energy minus 82 kilojoule, minus 82 kilojoule. When you can solve this, 4 fours are 16 and 4 fours are 16, and this is 4 2s 8. So you can get, my dear students, minus 82 kilojoule. So this is your answer. Question number 16, we get answer, that is B. B is the correct answer. Now my dear students, we can see the question number 17. The frequency of radiations emitted when the electron falls from n is equal to 4 to n is equal to 1 in a hydrogen atom will be the given ionization energy of hydrogen is equal to 2.18 into 10 to the power minus 18, and this H is the 6.26 into 10 to the power minus 34 joule. Here, my dear students, we can take the formulas. Number 1, you know the energy E is equal to H nu. So my dear students, what is the nu? Nu is equal to E upon H. My dear students, for hydrogen atom, we can get the energy of electron for hydrogen atom. My dear students, we get the energy of an electron, that is minus 21.8 into 10 to the power minus 19 joule, and divided by the n square. This is a joule per atom. Now my dear students, you can see the delta E, change in energy, that is minus 21.8 into 10 to the power minus 19, or you can say this 2.18 into 10 to the minus 18. You can also say that into 1 upon n 1 upon 4 square because here electrons are go to the 4 to 1. So, it is a 1 upon n1 square, 1 upon n1 square minus 1 upon n2 square. So, 1 upon 4 square upon 1 upon 1 square. So, my dear students, you can get the values. When you can multiply these values, you have the values of 20.44 into 10 to the power minus 19 joule per atom. Here when you can get the delta E, you can put this E values in this frequency because he want the frequency of radiations emitted. So, my dear students, nu is equal to E upon H. Here you can put the values of nu, this E values 20.44 into 10 to the power minus 19 upon Planck constant, that is 6.626 into 10 to the power minus 34, which is given in numerical. Then, my dear students, you can get the 3.08 into 10 to the power 15 per second. So, this is the nu, number 1, number 2 and number 3. Put the value and get the answer. So, my dear students, you can go the answer C, question number 17. You can get the answer C. First of all, E is equal to h nu, you can get the nu frequency because question is asked the frequency of radiations emitted, and when this n is equal to 4 to n is equal to 1, you can put the this formula and values and get the answer. Then you can calculate delta E. Now, my dear students, we can go to the question number 18. Here in hydrogen atom, energy of first excited state is minus 3.4 electron volt. Then find out kinetic energy of same orbit of hydrogen atom. My dear students, we can say the what is the formula which are used here. Here, what is the formula of kinetic energy? You know very well, kinetic energy is equal to half mv square. So, my dear students, you can put these values, and this half mv square is equal to, we can write here pi e square upon nh की power into 2m into 2m. We can write the kinetic energy formulas. Now, my dear students, we can see the total energy. Here total energy. That total energy is equal to, total energy means En. En is equal to minus 2 pi square m e की power 4 charge of electron divided by the n square h square. So, my dear students, you can see here that is the formula you have, and minus pi e की power 2 upon nh की power 2 you can write in this way and into 2m, and that equal to your energy of electron, that equal to minus kinetic energy. Now, my dear students, kinetic energy that equal to minus En. You can get here kinetic energy minus En, or En barabar minus kinetic energy. So, my dear students, we can see here energy of first excited state is minus 3.4 electron volt. So, kinetic energy of same orbital n is equal to 2 will be that equal to plus 3.4 electron volt. So, your answer is question number 18, your answer is A. Here kinetic energy is the plus 3.4 electron volt, because kinetic energy is the inverse of energy of electron. So, my dear students, you can get the answer plus 3.4. Now, we can go to the question number 19, who modified Bohr's theory by introducing elliptical orbits for electron path. My dear students, you can go to the Sommerfeld. Sommerfeld, when this is the nucleus and here these are the circular path, and this circular path is given by the Bohr. But according to this Sommerfeld, electrons are rotate around the elliptical path. just like Earth. So, this is given by Sommerfeld. So, it is called modified of Bohr theory. Now, we can see the question number 20. Here the Bohr's orbit radius for the hydrogen atom n is equal to 1 is approximately 0.530 angstrom. The radius for the first excited state. Here my dear students, you can put the formula and concept. We can see here for 9th orbit of hydrogen atom, that equals to Rn is equal to n square into R1. Here my dear students, here R2 is equal to 4, because here he said the first excited state. So, first excited state 2 to the 4. So, 4 into R1 is equal to 0.53, that is angstrom. So, my dear students, you can get the 2.12 angstrom, because here we can take the values in angstrom radii. So, my dear students, you can go to the answer D here, because here 0.530 angstrom is already given in the numerical. So, first excited state is the n is equal to 2. 2 to the 4 here, put the values and get the answer. Your answer is 2.12. This is the formula, my dear students, and this is the concept. Now, we can see the question number 21. Here in a Bohr's model of an atom, when an electron jumps from n is equal to 1 to n is equal to 3, how much energy will be emitted or absorbed? Formula and concept of this question. Here my dear students, we can see that what is the formula? Here energy of an atom when n is equal to 1, that is E1 is equal to minus 1312 upon n square in ergs. Here unit is erg. So, you can put here minus 1312. So, my dear students, in n is equal to 3, it is called E3, that equal to minus 1312 upon n is equal to 3. So, it is a square of 3, and you get the minus 1312 upon 3 into 3 9 and 9 into 3. So, you can get the 3 ka square 27. Answer is minus 145.7 kilojoule per mole. Now, electrons are jumped from n is equal to 1 to n is equal to 3. So, my dear students, here E3 minus E1, then equal to minus 145.7 minus 1312. Here my dear students, that arc 1 arc is equal to 1 joule. So, minus 1312 joule, both are same. So, here minus 1312. So, both are minus, and you can get the plus, minus minus plus, minus minus plus, and minus 1312. You can get the 1166.3 kilojoule. Now, my dear students, E3, that relationship E3 minus E1, that equal to 1166.3. This is divided by 6.023 into 10 to the power 23 Planck constant. Your value is 193.6 into 10 to the power minus 23. Now, my dear students, it is called in joule, it is called 193.6 into 10 to the minus 13 erg, or you can say that 0.1936 into 10 to the power minus 10 ergs. So, your answer is question number 21 D. You can get the answer D. First of all, you can take the formula, convert into joule, and erg and joule are both are same, and you can get the answer erg. Now, my dear students, we can take the question number 22. The radius of hydrogen atom in the ground state is 0.53 angstrom. The radius of Li plus 2 ions in a similar state. Which formula we can use here? Formula and theory. Here in a ground state, hydrogen atom radius r that equal to 0.53 angstrom. Here my dear students, Z is equal to 1 for hydrogen atom. So radius of Li plus 1, it is a Li plus 2 ion, like hydrogen ion, that equal to radius first orbit into n square number of shell upon atomic number. You can put the values r is here 0.53 into n. Here the radius of Li similar state means 1, n is equal to 1, similar state upon Z, lithium Z is equal to 3. So my dear students, you can get the answer. It's a 0.53 upon 3, means you can get the answer 0.17 angstrom. So this is your answer, 0.17 angstrom, radius of Li plus 2 ion, r into n square upon Z. Put the value and get the answer. Now my dear students, we can go to the question number 23. The energy of electron in the 9th Bohr orbit of hydrogen atom is, what is the formula? Your formula is same, En is equal to for electron volt minus 13.6 upon n square electron volt. So for 9th orbit, it is a minus 13.6 upon n square. So my dear students, your question number 23rd, your answer is C, energy of electron, but you can here put the value of negative sign for electrons energy. Now we can go to the question number 24th. The spectrum of helium is expected to be similar to that of. My dear students, here you can see what is the concept. Same number of electrons species, same number of electron species gives same spectrum. Same number of electron species gives same spectrum. So you can see here spectrum of helium. For example, atomic number of helium is 2. So you can see which species in which 2 electrons are present, that is lithium plus, because lithium 3 atomic number is present, and when remove the 1 electron, it gives Li plus 1, means 2 electrons similar to this is spectrum is also same. So my dear students, you can go question number 24th, answer is B. Now we can see here question number 25th. If r is the radius of the first Bohr orbit, the radius of 9th Bohr orbit of hydrogen is given by. What is the formula, my dear students, which are used in this question? Formula is radius. You can learn of this formula, radius of 9th Bohr's orbit is n square into r0. r0 is the radius of the first orbit. r0 radius of the first orbit. So my dear students, you can go the question number 25th, answer is A, r into n square. Now my dear students, we can go to the question number 26. This question is also asked in NEET 2019. In the hydrogen atom, the de Broglie wavelength of an electron in the second Bohr orbit is given. The Bohr orbits A0 is equal to 52.9 picometer. Here my dear students, we can use the formula which is given in question number 25. Here my dear students, we can use the formula Rn is equal to n square into A0. So my dear students, n square is equal to second Bohr orbit, put the values. A0 is given by 52.9 picometer. So you can get the 4 into 52.9. So it is at 211.6 picometer. Here you can see that this formula Rn is equal to n square upon n square into z into a square or R0. This formula is used here. We can use here. This formula is given in 1988 and formula is used in 2019 NEET exams. So my dear students, you can learn the formulas which are used in different exams in the different ways, but formula is same. So your answer is A, 211.6 picometer. Now my dear students, we can see the question number 27. A 0.66 kilogram ball is moving with a speed of 100 meter per second. The associated wavelength will be. Here my dear students, which formula you can use? My dear students, we can see the formula lambda barabar. It's a de Broglie wavelength. So lambda barabar h upon m into v. It's a de Broglie formula. Here h it is given by 6.6 into 10 to the power minus 34. Here mass of an ball. Here my dear students, mass of an ball is 0.66 in kilogram. Here what is the velocity? Velocity is 100 meter per second. You can put the values and my dear students, you can get the result. And your result is 1 into 10 to the power, because 0.6 it's a cancelled with each other. 0.6 is cancelled, 1 0, 0.6 cancelled, 2 0, 2 0 are cancelled with each other here. You can see this cancel 1, 10 to the minus 34 coming down, it is a 10 to the power 35, 34 plus, and these are cancelled with this 10 to the power 34 and 0, 35. So my dear students, you can get the, this 10 is multiplied by the 10 to the power minus 34. So you can get the 10 to the power minus 35 meter. This is your wavelength of the this 0.66 kilogram ball. So my dear students, you can go the question number 27. C option is the correct option. Now my dear students, we can go to the question number 28. If uncertainty in position and momentum are equal, then uncertainty in velocity is. It's a Heisenberg uncertainty principle, my dear students. And what is the concept? Here my dear students, you see the delta P into delta X that equal to or greater than h upon 4 pi, or you can see that delta P is the m into delta V equal or greater than h upon 4 pi. My dear students, when delta X is equal to delta P, both are same here. It means delta X square, it is a delta X square. M into delta P into delta X. M into delta P is equal to delta P. So into delta X that equal to or greater than h upon 4 pi. Now delta P is equal to delta X. So my dear students, you can write here, this is delta P is right here delta X. And when delta P is right here delta X, so it's a square. It's a square of m into delta P. So you can write here m into delta V square, and that equal to h upon 4 pi. Now my dear students, when you can put the this delta V only and m here, it is in a square and it is not a square. So delta V is equal to 1 upon 1 upon 2 m, then that 1 upon 2 m and this h upon 4 pi. So, delta V you can get the delta V, this is the h upon 4 pi 1 upon 2 m, because in position and momentum, position my dear students it is a delta x and here momentum is the delta p, both are equal in this equation or question. Then he want the uncertainty in a velocity, So, my dear students you can get the 1 upon 2 m into root h upon this, the root h upon pi, the root h upon pi. So, my dear students you can get the answer 1 upon 2 m into h upon pi, that is the C option is the correct answer. So, my dear students you can get the question number 28, C is the answer. First of all you can use the formula delta P is equal to into delta x, that equal to or greater than h upon 4 phi, and you can put the values of delta P, that is m into delta V into delta x, both are equal my dear students, delta P and delta x is equal, it is given in this question. So, you can square of this, you can use the square of delta P square. So, delta P square means m into delta B square, and when you can only get the delta V here. So, delta V here that equal to root of h upon 4 pi and m is here 1 upon 2 m into h upon pi. Here root 1 upon 4 means 2. So, you can also write this 1 upon 2 m into root h upon pi.